So in order to understand what atoms will do with their electrons, I need to discuss the Octet Rule. And what the Octet Rule tells you is that atoms are most stable when they have 8 electrons in their outermost energy level. Another way of saying this, because the electrons in your outermost energy level are your valence electrons, atoms are most stable when they have 8 valence electrons. That is the ultimate goal. Okay? Well, there are naturally atoms that will have that stable, what we call octet, and those are your noble gases. So if you notice in this diagram here, I'm going to quickly write out the electron configurations that we see. So notice I've got first energy level, second, third, and fourth. So what these diagrams are doing is they're actually combining orbitals together. So what this would be written out, the electron configuration, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. Okay, so let's make sure we see how that's represented. Okay, first energy level has 2 electrons, 1, 2. Okay, second energy level in yellow, you can count it out, they're 8. In the third energy level, it's got 18, which is consistent with this electron configuration, because we've got 2 from 3s, 6 from 3p, and 10 from 3d. And then for the fourth energy level, it's got 8 again, which is 8 in its outermost energy level. So krypton here has 8 valence electrons. Okay, xenon here, if we write out the electron configuration, 1s2, 2s2, 2p6, all the way out. I'll write it super quickly. Notice the first energy level has 2 electrons. The second energy level has 8. The third, you can look at the diagram and look at my electron configuration. The third has 18. The fourth has 18 as well. Okay. And the highest energy level there, which is 5, has 8 again. So at this point, I'm hoping you'll take it from my word. All of the noble gases have 8 valence electrons. And you might be saying, whoa, 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 whoa. Actually, I see a diagram where there aren't 8 valence electrons. And you are right. Helium is always the odd man out. It has, because it only has that first energy level can only have 2 electrons. So helium is actually stable with just 2 valence electrons. Okay. Well, why did I go through all of this? Noble gases are stable, and all atoms want to have the electron configuration of a noble gas. That is when they will be most stable, and that is their ultimate goal, if atoms were to have a goal, is to be stable. So how exactly can they achieve that? Well, let's figure it out. So if we look at our periodic table, let's look at the first column. Regardless of the principal energy level, all of these elements will have 1 valence electron, okay? No matter what. Remember, the electron configuration of hydrogen is 1s1, so that would be 1 valence electron. Lithium, remember, is 1s2, 2s1, so it has 1 valence electron because 2 is the highest energy level. If I went on to sodium, its electron configuration would be 1s2, 2s2, 2p6, 3s1, so it would have 1 valence electron, okay, and so on and so forth. So all of the elements in the first group have 1 valence electron, okay? If you look at the next group, the electron configuration for beryllium is 1s2, 2s2, so it has 2 valence electrons. If you wrote out the electron configuration for anyone in this group, they would all be 2 valence electrons. And if you notice, we're going to start to have a trend. We're going to skip the transition metals. If I wrote out the electron configuration for boron, for example, it's going to be 1s2, 2s2, 2p1. Okay? And if you count, that's going to be 3 valence electrons. So what you should notice, I've got 1, 2, 3. As you move across, the number of valence electrons increases until you reach your noble gases. And we had already said your noble gases have 7 valence electrons. Okay? And remember, the goal of every atom is to achieve the electron configuration of a noble gas. Okay? So let's talk about how that can be done. All right. I'm going to start on the right-hand side, and then we'll go back and look on the other side. So here, for my group with fluorine here, okay, they have 7 valence electrons. Well, what can they do to get 8 valence electrons? Well, they can gain a valence electron to get the electron configuration of a noble gas. So fluorine, for example, which is 1s2, 2s2, 2p5, all it has to do to get the electron configuration of neon is it has to gain 1 electron. And then it'll be 2p6, and there'll be 8 valence electrons. So if it gains an electron, that means it will have a -1 charge. So all the atoms in this group, in your halogen group, will have a -1 charge when they form an ion to be stable. Oxygen, which has 6 valence electrons, and anyone in its group, how can it get 8 valence electrons? It can gain 2 valence electrons. For the next group, with nitrogen's group, what can it do? They can gain 3 electrons. So these are the charges of the atoms when they form ions. Okay? Let's go back to group 1 and look at hydrogen's group. Okay? These guys have 1 valence electron. So using the thought process we just went through, they would need to gain 7 electrons in order to get an octet. Or, if you think about it, let's look at sodium really quickly. Sodium's electron configuration is 1s2, 2s2, 2p6, and then 3s1. Well, it would have to gain 7 electrons, or if you notice, if I just got rid of the 3s1, I now will have 2 plus 6, I'll have 8 valence electrons, and so it will have the electron configuration of a noble gas, and it will be stable. So what metals do on the left-hand side, instead of gaining electrons, they actually lose electrons. So the charge for group 1 is going to be +1 because they're losing 1 electron. Okay? Group 2, how many valence electrons does it need to lose? It needs to lose 2. Okay? If we look at, for example, aluminum, to figure out the charge for that group, it has 3 valence electrons, remember? So what I can do is simply lose those 3 valence electrons in order to have 8 in the new outermost energy level. And so these guys will have a +3 charge because they're going to lose 3 electrons. So valence electrons counting. As you move across the periodic table, okay, group 1 has 1, group 2 has 2, go over to boron's group, 3, 4, 5, 6, 7, 8. For charges, group 1 has a +1 always, group 2 has a +2 always, group 3 has a +3. Notice we skip group 4 or group 14 simply because it's not that simple when you have 4 valence electrons, because do you gain 4 or do you lose 4? So they do not achieve a normal, regular, reliable charge. We'll talk about that later. Okay, so +1, +2, +3, skip, -3, -2, -1. And what do you think the charge for your noble gases will be? Well, it would be 0 because they don't want to gain or lose any electrons because they are stable already. Okay? And that's it.